Hello everyone, and welcome to the first episode of BMED 202. In this, our first episode, we will look at force and how it relates to engineering drawing. So, what is force? Force is a push or a pull on a body that results from the body's interaction with other bodies, right? And the SI unit of force is newtons, right? Force is referred to as a vector quantity. This is so because force possesses both a magnitude and a direction. Let me demonstrate this. Let's say I have a football here, which is a body, and a defender proceeds to kick the ball with a force of 3 newtons. The ball will move in a particular direction as a result of the force that is exerted on the ball. Thus, force is classified as a vector quantity because force, which is a push or a pull, happens in a particular direction, right? So, let me give an example of a quantity that is not a vector quantity. Measurement. This ruler, or this eraser, that I have in my hand here, measures approximately 5 or 4 centimeters. That length is not a vector quantity because length cannot be measured. Length doesn't have a direction. You would not say that this ruler or this eraser, measures 5 centimeters to the north or 5 centimeters at an angle of 60 degrees. It just measures 5 centimeters. Thus, it's not a vector quantity. So, back to forces. This ball, when kicked, is moving in this direction because of this 3 Newton force. Let's say, as the defender is proceeding to kick the ball out of danger, an attacker proceeds to slide in and kick the ball in the opposite direction. Now, when both attacker and the defender kicks the ball, let's say the attacker kicks the ball at a greater force of around 5 newtons. As a result of both forces being applied on the ball at the same time, a new force will be birthed. And this new force will be called a resultant force. Now, this force comes as a result of both forces acting on the ball at the same time. And a new direction will be established. So initially, there was a force going in this direction. There was a force going in this direction. Now, 2 angles. So let's call this angle X, this angle Y. So we don't know these angles at this point in time. And we don't know, call this force theta. So this is, you don't know the force as yet. All right? So this force is called the resultant. And note this term. This force is called the resultant force. Now this body is in motion as a result of 2 separate forces in 2 separate directions being applied to the ball. Now, this ball is not in a state that we would call equilibrium. And let me define that term now. I'm going to present another ball. Let's say that as the defender runs in to kick the ball, using a force of about 3 newtons, the attacker proceeds to kick the ball in the opposite direction, also at a force of 3 newtons. As a result of these forces acting on the ball will remain in a state of equilibrium. This is due to the fact that this 3 Newton force is cancelled by this other 3 Newton force by virtue of the fact that both forces are the same, but they are acting in the opposite direction. Now, this body is in what we call equilibrium. All right. So this body over here is not in equilibrium. This body is in equilibrium. I'm going to reproduce this drawing over this side. So you have the first force of 3 newtons. You have the second force, 4 newtons. I realize that I made a mistake over here. This is supposed to be 5 newtons. This is supposed to be 5 newtons. So bear with me. If this body, which is, by the way, not in equilibrium because the resultant force will be applied by virtue of these forces combining. So this body will now be moving in this direction as a result of both forces being applied. Now, if this body is supposed to be like this body, a new force will have to be applied, a third force. This third force has to be opposite in direction to the resultant force, but has to be of the same magnitude of this resultant force. Let's now give this resultant force a value. Let's say it was 4 newtons. You would now need a force of 4 newtons, but in the opposite direction. So this force is 4 newtons. All right. All right, let this stay here. We're going to change something. 4 newtons. Right? This body, as a result of the equal but opposite force to the resultant force, will now be in equilibrium, meaning the body will now be stationary due to the fact that a equilibriant force is added. So there are 3 terms that I've just introduced you to: the resultant force, or a resultant force, equilibrium, and an equilibriant force. So let me do a quick review of what I've just said. A resultant force, or a resultant, is achieved when 2 or more forces act on a body and the sum of all forces is achieved. Now the combination of these forces also will produce a new direction. Initially this force was acting to the east. This was acting approximately northwest. Now you have a northern force acting in upwards right? This new force that is created as a result of both forces is referred to as a resultant force. Over here now, you have a body that is in equilibrium, and that is a state that the body is in as a result of all the forces acting on the body cancelling out each other, thus rendering the body stationary, right? So that's a body being in equilibrium. Now, this same body, I've replicated it over here. Now, if you want this body that is not in equilibrium, by the way, because it's moving in the direction of the resultant force, if you want this body to become in a state of equilibrium, you have to add a force that is equal but opposite to the resultant force, and this force will now be called the equilibriant. So there's a relationship between the equilibriant and the resultant. They have to be equal in magnitude but opposite in direction, right? Once a body is moving in a particular direction as a result of forces being added, you can add what we call an equilibriant force to render that body in a state of equilibrium. So you have resultant force, addition of all forces causing a force, that is called the resultant force. You have the equilibriant force, which is another force that can be added to all those two initial forces that will bring the body in a state of equilibrium. Now, thank you for watching this video. In future videos, we will look at how we can derive resultant forces and equilibriant forces using various graphical means. Have a good day.